This tape is on polynomials, where we'll learn how to add and subtract only. There will be another tape for multiplication and division of polynomials. Let's look now at the notes at what a polynomial is. A polynomial is an expression of terms. This 1 is a term, the 3x is a term, this is a term, this is a term. Now, a term is something that's made up by a combination of multiplication and or division. No addition, no subtraction. Just an individual term, then, are some numbers and letters combined by multiplication and or division. We'll basically look at just multiplication combinations. So this is an expression made up by two terms. Here's the subtraction of this term from this term. That's a polynomial. This is a polynomial. This is a polynomial. All right, let's look at example 4. This is a polynomial. Okay, it's made up of the term 2, the term 3x, the term 5x squared. This is a term, this is a term, and this is a term. Example 5, a polynomial. X cubed is a term, 3x squared y is a term, 4y squared is a term. This is a polynomial. This is a polynomial made up of terms. And here's a term that's made up of multiplication and division. Okay, but that's a term. And so an expression made up by terms that are added or subtracted is the concept that we want you to know about polynomials at this point. Now, let's look at all 7 of these and talk about some things that you need to know for terminology. All right, first of all, monomial. Monomial. Mono. 1. This is a monomial. It only has one term. This is a monomial. This is a binomial. 2 terms. 2 terms combined in an expression. Binomial. Trinomial. 3 terms. Trinomial. Monomial. Trinomial. That's how simple it means. Okay? Poly means many. Polynomial means many terms combined into an expression. So if we only have 1, that's a monomial. If we have 3, it's a trinomial. If we have 2, it's a binomial. And that's basically the ones you work with in this algebra course. All right? So we've learned monomial, binomial, trinomial. Now let's learn 2 other terminologies. First of all, let's learn coefficients. Coefficients are the constants in front of the terms. Coefficient here is a 3, or a minus 3 if you want to consider that. Coefficient is 4 here, or minus 4. Coefficient is 3. Coefficient 5. Coefficient 5. This is the coefficient of x to the 0 power. X to the 0 power is 1. So when you have just a constant, it still is times an x. Okay? So it happens to be the coefficient of x to the 0 power. Anything to the 0 power is 1 except 0. 0 to the 0 power is not 1. As long as x is not 0 here, then all of this is the same thing as 1. All right, that's the word coefficient. Now, the next one that's a little tougher is the degree of the polynomial. The degree of the polynomial. Now, the degree of the polynomial is the highest power of the letters. Now watch, this is x cubed, that's third power. This is squared times 1, that's third power. This is 2 power. So the highest we have here is 3. So the degree of this one is the 3rd degree. The degree here, the power is 1. Remember now, the power here was 0. The power here is 2. So this is a 2nd degree polynomial. This is a 3rd degree polynomial. This is a 0 degree polynomial. Remember, x to the 0 power. This is a 0 degree polynomial. This is a 3, and here's 3 and 1, so that makes 4. This expression is a 4th degree polynomial. The highest power of the combination of the powers. So we just check them all and see which one is the largest combination of powers. This is 4, therefore this is a 4th degree polynomial. Let's look over here. This is a 4th degree polynomial. There it is. This is a 1st degree polynomial. This is a 1st degree polynomial. All right? So that's the explanation of degrees of polynomials. So we've kind of got the terminology now that's necessary for this exercise in your textbook. Now let's look at the working of the problems. Looking in your notes and then looking at the tape here, you see this big, long, complicated looking polynomial. Okay. Well, what degree is it? Well, let's see. We got a 2, and we have 3 here, and 3, 2, 2, 2, 3. So that's a 3rd degree polynomial. Now how do we add? How do we subtract polynomials? What we do is add apples to apples, oranges to oranges, pears to pears, and don't mix them. Apples to apples means if I have an x squared by itself, x squared, I go look for another x squared. Do I have another? Oh, here's another x squared. Okay, then I can add x squares to x squares. So what is 3x squared added to a minus 5x squared? Well, now, wait a minute. Listen to this. X squared. Let me talk about the x squared y. This is an orange. So we're going to find another orange. X squared y. X squared y. Nope, not one. So we leave it alone. That'll just be by itself. So we'll write it down. 3x squared y. All right, an xy squared. That's a pair. Let's see. Pair. Xy squared. X. Don't have an xy. I don't have another one of those. So we'll just write it down. Xy squared. All right. Let's see. What's next now? We got that one. Now let's take a 2x here. 2x. That's a tangerine. Well, let's see. Can we find another x? Yeah, there's another x. So we'll write it down. 2x and plus a 7x. All right. What else is the same? Here we have a 3y minus 3y and a minus 8y. So we have a minus 3y and a minus 8y. And then we have some bananas. Okay, we have an xy and an xy. So we have a 5xy and a 3xy. And we have a minus 13 and a 4. Now that's what I'm saying. You don't add anything but the same type of term. X squares to x squares. Look at the whole picture here. You add x squares to x squares. You add x squared y's to, well, we don't have any more x squared y's. XY squared, don't have any more, so we just leave those alone. We add x's to x's, y's to y's, xy, xy's, numbers to numbers. All right, now let's go back over and look at how we add these. This is where the word coefficient comes in. What we do is we say 3 means we have 3 apples, and we have minus 5 apples. So what we're saying is we add 3 of these objects to minus 5 of those objects. So we add the coefficients. So that answer is minus 2x squared. Now we don't have anything to add to this, and it was a positive, so we just write it down. We didn't have anything to add to this or subtract from it, so we just write it down. Then adding the x's, we have a plus 2x and a plus 7x, which is adding the coefficients is a plus 9x. Now notice in my answer I put my x, y's in first. I'll talk about that. It doesn't make any difference which one you write down first over here. Just add the x's to the x's, the y's to the y's, the xy's to the xy's, the x's to x's, and so on and so forth. And then just write them down as you add them together. All right, now we're adding the y's, so we have a minus 3 of those added to a minus 8. A minus 3 and a minus 8 added is a minus 11. And then we had 8 of these, adding the coefficients and then adding the numbers. So we get this answer. Now, as I said before, it doesn't make any difference in the order, just as long as you get all the x's added to the x's, y's to the y's, xy's to xy's, and so on. But let me explain how they do this in textbooks. They have kind of an order of writing it, and that is you take x, the letter alphabetically, in other words, x comes before y in the alphabet, therefore we start with x's. We take the highest power of x's by itself and then go down. If it's connected to a y, we go down, and then we let x go down to the next power connected to y's. Goes down. Okay, y has to go down also. And then x's, and when we run out of x's, we start with y's by themselves and that type of thing. That's the process that they use for answers. That doesn't make it wrong if you put this first and this second and this fourth and whatever. Just as long as you listen to what I'm saying, and that is you add x squares to x squares, you add x squared y's to x squared y's, you add xy squares to xy squares, you add x's to x's, y's to y's, xy's to xy's, numbers to numbers. And when you do add all these things, you're adding the coefficients, the numbers, because what this is saying is you have 5 of these and you have 3 of these. Therefore, your sum is 8 of those. All right, now let's look at several examples. Okay, looking at the examples on the back of the page, the first one says add 3x and 5x. Remember what I said now? This is apple to an apple, and we add the coefficients. Therefore, this would be 8x. Just how simple it is. All right, now let's look at the next example. It says add this trinomial to this binomial. Well, it says add x's to x's, x squares to x squares, numbers to numbers. So what we're going to do then is we're going to say, okay, add the x squares to x squares. There's an x squared and there's an x squared. That gives us 2 x squares. Okay, here's an x and an 8x. That adds together, gives us 9x. And in the numbers, that's a minus 7 and 0, so that's a minus 7. So we can do it that way. Another way is to write it this way. Write down 5x squared plus 8x minus 7 added to x minus 3x squared. Now, when you remove the parentheses, plus times a plus x is a plus x. Plus times a minus is a minus. So removing the parentheses, we have that. And now we just do what? Same thing. Add the x squares to the x squares. So here we have 5x squared and a minus 3x squared. That adds up to 2x squared. We have a plus 8x and an x. That adds up to 9x. We have a minus 7 and 0 adds up to minus 7. All right? A third way of doing it. Whichever way you feel comfortable with, use it. You don't have to do all 3. Is to write it underneath each other, just like you do numbers when you're going to add regular numbers. Okay? But place the x squares underneath the x squares. Place the x's underneath the x's. If this has no symbol in front of it, then it's a plus. And then you add, you get a minus 3 and a plus 5 adds to a plus 2, plus 8 plus 1. Even though it's not written there, that's implied as a 1. Plus 8 plus 1 of those is 9. 7 and 0 is minus 7. All right, let's look at the next example. Okay, we want to add 3 of these together, all right? Well, let's just write them all down then. We can write down 2x cubed plus 3y added, we'll write x squared minus 5y added 4x cubed plus 2y, and we remove parentheses, so we'll have 2x cubed plus 3y plus x squared minus 5y plus 4x cubed plus 2y minus 7. Get rid of all the parentheses. And the reason I'm showing you this, because when we go to subtraction, this becomes an important process, this parenthesis concept. All right, now we add apples to apples. Well, there's an x cubed and an x cubed. So we add those, we get 6 of those. Okay, and let's see, x squares. No more x squares, so we'll just write it down. X's, there's not any x's. Y's, here is a y and a y and a y. Well, wait a minute, how much do these add up? There's 3 and a minus 5 and a plus 2. Let's see, 3 and minus 5 is a minus 2. A minus 2 and a plus 2 is 0. So all those add up to 0. So I don't write any down. And then we have a minus 7. All right. Now let's step back and look at that and see what we think about that. Does that look right? Okay. All right. So that's how you add. Now, we could have just started out up here. Let's just do it this way. The shortcut method. Add apples to apples. Here's an x cubed and there's an x cubed. Add them together. That's 6 of them. There's a y, 3 of them. Minus 5 of them is minus 2. Plus 2, 0. No y's. There's an x squared. Not any more x squares. Write it down. Numbers, minus 7. No other numbers. No other constants is what the terminology is. So we write it down. So we can do it all in one step if you want to, but just coming up here, adding apples to apples, oranges to oranges, and so on and so forth. That's how you do it. That's all there is to adding polynomials. Now let's look at subtracting polynomials. Subtracting polynomials becomes a more careful process. It's the same thing as adding, because to subtract, you simply change the sign of the bottom one and add. So we're still using the same concept as adding. But let's go through the process. It says subtract this from this. That means that what we want is 3x minus the 5x. We want 3x minus this object. When it says subtract this from that, then this goes behind. Okay, or underneath. Now what is 3x minus 5x? Coefficients. 3 apples minus 5 apples is a minus 2 apples. That's one way of doing it. Another way of doing it is the old subtraction method that you were taught with numbers, and that is write the top, the 3x down, and then say minus the first one. Now, what is 3 apples minus 5 apples? The answer is minus 2 apples. So either way. All right, let's look at the next example, see how this works with the same concept. Okay, we have this subtracted from this, which means we write this one first, minus, in parentheses, 5x squared plus, and that's an 8x, 8x minus 7. All right, so this is x minus 3x squared. Removing parentheses, minus times this is a minus 5x squared. Minus times a plus is a minus 8x. And a minus times a minus is a plus 7. Remember now, and this is why I do that parentheses. When this is a minus in front of it, then you must distribute that among every one of the inside terms. All right, now we add apples to apples, oranges to oranges. Well, let's see. We have x squares, so we have a minus 8 of those. X's, we get a minus 7 of those. We have a minus 8 plus 1 of them. And the numbers, we have a plus 7. Okay? So when you subtract, now, this becomes important that you do the parenthesis concept. Now, when we had adding, we could have just thrown away the parenthesis. But with subtraction, it's going to change the sign of the inside. One of the most common mistakes that all of us make by carelessness. So change the signs of the inside and then add the coefficients of the apples to apples, oranges to oranges, and so on and so forth. Well, let's look at another way of doing it. Another way would be to write them down. We want x minus 3x squared, and we're going to subtract from it a minus. Okay, well, 5x squared goes here. The 8x goes over here. And the 7 goes over here. Now, when we're subtracting, when we subtract, we change the sign of the bottom one and add. Change the sign of the bottom one and add. Change the sign of the bottom one and add. And there we have it. And that's the same answer as a while ago. A while ago we had it written as 8x squared minus 7x plus 7. This is the same answer. This answer is just as good as that answer. You're going to see it written this way in back of books and that type of thing. Because they do the highest power of the same letter, descending order. But this is the same answer. All right, let's look at the next example. This again is why you have to be careful. Take your time, think, be careful. We're going to subtract from the 2x the minus 3x. Subtraction. This is a negative sign. This is a subtraction sign. Big difference. So we're removing parentheses. We get plus 3x. Final answer is x. Okay? Now the other method would be where we write this down, and we write this down, and we subtract. Now when we subtract, we do what? We change the sign of the bottom one and add. So we get the same answer. All right, now let's look at the last 6 examples. Okay, looking at these that say simplify. In other words, it's kind of already set up for us, so now we just simply add apples to apples, oranges to oranges. Well, let's see. Here is a y cubed and a y cubed. So we have 1 of those plus 2 of those. That makes 3 of those. We have a y squared. No more y squares. So we have a plus 4 of those. Y's, we have only a y here, not anymore, so it's minus that one. Minus 1 of those. And then numbers. Okay. Minus 10 and a plus 7. A minus 10 and a plus 7 add up to a minus 3. And that's it. In other words, add apples to apples, oranges to oranges, pears to pears, numbers to numbers. Okay, next example. Have an a squared. Oh, here we have another a squared. So we have 3 of those. AB, 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 AB. Oh, we have some more ABs. So we have a minus 3 of them and a plus 3 of them. Adds up to 0. So those are dropped out. We have a b squared. Okay. And a b squared. Have 1 of these. Minus 2 of them is a minus 1 of them. Okay. Next example. Now the next example comes back to order of operations that we've learned before in the class. Order of operations. One of them is remove parentheses before you add and subtract. So we need to remove the parentheses. So we need to rewrite the problem down. And removing parentheses, distribute this times that, so minus 8x. This times that is a plus 12y. And now we have all parentheses removed, powers removed. Now we add apples to apples, oranges to oranges. X's added to x's, minus 7 of those. Y's to y's, plus 9 of those. Okay. See how simple this is? All right, let's go to the next example. Again, order of operation, remove parentheses first. So this will be y minus 2 times 1x is a minus 2x. A minus 2 times a minus y is a plus 2y. A minus 3x. A plus 2 times plus 3 is a plus 6x. A plus 2 times a minus 1 is a minus 2y. Now we add apples to apples. All right. X's, what do we have? We have a minus 2 of them. A minus 3, that's a minus 5, adding minus 5. And a plus 6 is a plus 1 of those. Okay, then adding y's, we have 1 plus 2, that's 3 of those. Minus 2 is 1. So we get just plus y. Okay? All right, looking at the next example, we have parentheses and brackets. In other words, our double parentheses. So what do we need to do here? Remember, we work inside out. So you should copy down the brackets and then work with the parentheses. Minus 2 times this is a minus 2x. Minus 2 times a minus 1 is a plus 2. All right. Now we remove the brackets, so it's a minus 12. Minus times a minus is a plus 6x. Minus times a minus is a minus 6. Adding apples to apples, that's 10 of those. And minus 12 and minus 6 is a minus 18. All right, that gets the answer. Now, we could have up here combined this to start with. We could have come in here and said, okay, this 4 and the 2 is 6, minus 2x. Then multiply. This is a minus 18, there it is. This is a plus 6x, added to that 4x. And so, yes, you can combine the inside before you remove the brackets if you wish. It works either way, just knowing that the distributive property, if this is a minus out in front, it's going to change the sign of everything inside there. All right, let's look at the last example. Here, all we do is remove parentheses. So let's copy down the first one, 2x to the 4th, minus x squared, minus 7. Removing parentheses, minus 3x cubed, minus 7x squared, plus 2x. Minus times this minus is a plus. Now, we have parentheses here, but if it's a plus sign, what does that mean? We can just kind of drop the parentheses. So it's a plus x squared, minus 3x, plus 1. Now, we add apples to apples, oranges to oranges. All right, x to the 4th. Not another x to the 4th, so we just copy it down. 2x to the 4th. X cubed. Let's go find the highest next. X cubed. No more x cubed. So that's a minus 3x cubed. X squares. There's an x squared. There's an x squared. There's an x squared. So we have a minus 1 of them. Minus 7. That's a minus 8 of those. Plus 1 is a minus 7 of those. Okay, let's see x's. Now let's look for x's. We have x's, x's, x's. Okay. So we have 2 of those. Minus 3 is a minus 1 of those. All right. Then we look for numbers. There's a minus 7 and a plus 1. So that's a minus 6. And so that's our final answer. This concludes then the tape on polynomials, addition and subtraction. All right. This concludes then the tape on polynomials, adding and subtracting.